Now we will discuss about the topic limit and continuity. First of all, we want to know about the what is limit, who developed, how it comes. Archimedes of Syracuse first developed the idea of limits to measure curved circle figure and the volume of the sphere in the 3rd century BC. By carving these figures into small pieces that can be approximated, then increasing the number of pieces, the limit of the sum of the pieces can give desired volume. जैसे ये है थोड़ा बड़ा पीस करके हम लेंगे तो ये अप्रोक्सीमेशन वॉल्यूम कम होगा, थोड़ा छोटा पीस कर देंगे तो वो अप्रोक्सीमेटेड वॉल्यूम ज्यादा हो जाएगा, एग्जैक्ट हो जाएगा. So that's why they taken in that way the size of the increasing the number of piece size small कर दिया, pieces ज्यादा कर दिया. So then the sum of the pieces can be given the desired quantity. Actually, they give the concept about the limit, how it comes. Now come to the father of limit. Father of limit, that is equal to Newton. Father of limit, that is Newton. Actually, Newton 1664, 1665, 1666 is geometrically they developed, but it is not published, but it is published in 71. And that time in 1670, Leibniz developed the analytically 1670 say analytically developed and also published the concept about the limit, so that father of limit sometimes it is called Leibniz, sometimes it is called Newton. Also sometimes also called father of limit Newton as well as Leibniz, both also called. But Newton developed first. After that, what is the definition of a limit? Definition limit 3. One is the epsilon delta definition. First, we will discuss about the epsilon delta definition. First of all, what is epsilon and what is delta? Now, epsilon is the smallest positive integer, positive number. Thus, that delta also is a smallest number, positive number. Which is in between 0 and 1. Definition of limit. A limit is the value that a function or a sequence which approaches as the input or index or approaches some value. Means, suppose y is a function fx, that a function is x plus 5 suppose. Whatever x value you put, that y value get. That means according to the x value, the function approaches some other value. That's actually about the concept of a limit. Now come to the what is the application of limit, how to what are the different area we can use in limit. Limits are essential. Here limits are essential to calculus and mathematical analysis in general, and are used to define continuity, derivatives, and integrals. And also it is used in many cases. You can say Iit-Jee. It is also used for astronomer purpose, space purpose, curve tracing purpose, for finding maxima minima purpose, whatever. Many areas it is for formation of for vibration purpose. Many areas it can use. Here, definition, that is absolute delta definition. That is also defined by Cauchy-HEINE. The limit of the fx at x is equal to c is L. If for any epsilon is greater than epsilon is small positive number, there exists a small positive number delta which is greater than 0, such that if the distance of x from c is less than delta, then the distance of f of x from L is less than epsilon. In mathematically, the difference between fx minus L ka magnitude is less than epsilon when x minus c ka magnitude is less than delta. That means, otherwise you can say limit f of x at x is equal to c is equal to L. This is the epsilon delta definition, which is developed by Cauchy and Hale. दोनों मिलके वो बनाया था. Now we can take another example. What the example say? If fx is equal to x square minus 1 by x minus 1 is given. Let's put x is equal to 1. Then f of 1 is equal to 1 square minus 1 by 1 minus 1, which is equal to 0 by 0. If you put direct value, then it is indeterminate form will come. Let's try to approach it closer and closer. That means when x is equal to 0.5, then fx is equal to x square minus 1 by x minus 1 comes 1.540. Then if you put x value 0.9, that is 1.940. If you put 0.99, then it comes to 1.99, then 30. Suppose if you put 999, it comes 1.9900. Suppose you put 9999, then it comes to 9999 single zero. Suppose you put 9999, that is 1.999, that is 59 will come. It means when it is closer to 1, it affects value also closer to 2. That means it is closer to 1. It is closer to 2. That the concept is given. In this way, we can find the limit value. Here, fx is equal to x square minus 1 by x minus 1 get close to 2 when x gets close to 1. Then the limit of x square minus 1 by x minus 1, which is fx, as x approaches 1 is equal to 2. That means you can directly write limit x square minus 1 by x minus 1 at x tends to 1 is equal to 2. This is the graph, which is 0.5, it comes to 1.5. When this is nearer to 1, it comes to nearer to 2. This is the line. So, similarly, another question also discussed by using epsilon delta definition. Here, when fx, here fx tends to L as x tends to L. How close? That's the difference, magnitude A minus B ka magnitude. Here, fx minus L ka magnitude is very small when x minus A is small. That means fx minus L ka magnitude is less than epsilon when x minus A ka magnitude is less than delta. That otherwise you can say for any epsilon is greater than 0, there is a delta greater than 0, so that fx minus L ka magnitude less than epsilon when 0 less than x minus a का magnitude is less than delta. A small example also in a real life situation we can say another example. That example is one is accelerator, that is x is 360 degree. Okay. Another is a speedometer, suppose speedometer, that is 0, that is 100, that is 200. This is fx, that is 200. Here, if it is that is 360 degree, हम एक्सीलरेटर घुमाएंगे तो ये टोटल स्पीड हो जाएगा 200 किलोमीटर स्पीड हो जाएगा, स्पीड हो जाएगा 200 किलोमीटर. दैट मीन्स इफ थोड़ा ही एक्सीलरेटर कम कर देंगे तो स्पीड कम हो जाएगा. मतलब सपोज थोड़ा कम किया 3.359 डिग्री कम किया, इसका मतलब वो 200 कम हो गया 199 किलोमीटर हो गया स्पीड. सपोज 359.9 डिग्री किया, इसका बढ़ा के 199.9 किलोमीटर हो गया. सिमिलरली 359.99 डिग्री लिया, मतलब एक्सीलरेटर घुमा लिया, इसका मतलब 19.99 लिए किलोमीटर आ गया. सिमिलरली 359.999 डिग्री लिया, इसका मतलब 1999 ओके 9.999 किलोमीटर आ गया. इसका मतलब क्या है, ये जो है अप्रोक्सीमेटेड वैल्यू दैट इज सपोज ए, ये जो है अप्रोक्सीमेटेड दैट इज इक्वल टू एल. So whatever the difference is less here, according to that difference also less. ये दोनों का difference if less होगा तो उस दोनों का difference भी less होगा. तो approximated value as well as here changes. Yes, ये एक्सीलरेटर कम होगा, मतलब एक्चुअली एग्जैक्ट है 360, ये नियरर है दिस ए, इनका डिफरेंस कम होता है तब ये एग्जैक्ट है 200 किलोमीटर एंड अप्रोक्सीमेटेड है, इनका डिफरेंस भी कम होगा. इसका मतलब है fx माइनस एल का मैग्नीट्यूड इज लेस देन सपोज वेरी स्मॉल 0.001, देन इनका डिफरेंस क्या है, x माइनस ए का डिफरेंस इज ऑल्सो लेस देन 0.001 होगा. या इसका मतलब है क्या ना, fx माइनस एल का मैग्नीट्यूड इज लेस देन एप्सिलॉन व्हेन x माइनस ए का मैग्नीट्यूड इज लेस देन डेल्टा. दैट मींस हियर delta value also we can say that is 0.001, del epsilon value we can say suppose 0.001, that is a small value. That's why this is called the definition. What the definition? fx minus l का magnitude is less than epsilon when x minus a का magnitude is less than delta. That's why limit is called limit f of x at x tends to a is equal to l. This is the limit. Okay, this is one example. Now similarly, one question we will do by using epsilon delta data. Question, what question? The limit 2x plus 3, 2x plus 4 at x tends to 3 is equal to 10. Step 1, let fx minus L magnitude is less than epsilon. Then fx का value क्या है? This is fx. fx का value 2x plus 4 minus 10. This is L. This is L. So here 2x minus 6 का modulus is less than epsilon. Now 2 taking common is a constant, so outside 2x minus 3 का magnitude less than epsilon. So x minus 3 का magnitude less than epsilon by 2. Let's say that is a delta. So next step will say let 0 less than x minus a का magnitude less than delta, that is 0 less than x minus a का a का value क्या है 3 is less than delta, so that's why 0 less than x minus 3 magnitude is less than delta प्लस में epsilon by 2 डाल दिया. Now 0 less than 2x minus 3 का magnitude is less than epsilon, that is 0 less than 2x plus 4, इसको लिख सकते हैं 2x plus 4 minus 10 लिख दिया, उसका magnitude less than epsilon. Now fx minus l का magnitude is less than epsilon. लिया था fx minus l is less than epsilon, हमको मिला क्या मिला, हमको मिला इधर क्या मिला ना, x माइनस ए का मैग्नीट्यूड इज लेस देन डेल्टा मिला, फिर हम x माइनस ए लेस देन डेल्टा लिया तो fx माइनस एल का मैग्नीट्यूड लेस देन एप्सिलॉन मिला. तो दैट्स व्हाई वी कैन से लिमिट 2x plus 4 at x tends to 3 is equal to 10. In this way we can prove the limit value. Here take another example. Prove that limit x square at x tends to 2 is equal to 4. Let epsilon is greater than 0 be an arbitrary small number. Let fx minus l का magnitude is less than epsilon. That implies x square minus 4, x square minus 4 का magnitude is less than epsilon. That implies x minus 2 factorize कर दिया into x plus 2 का magnitude less than epsilon. Here x minus 2 का magnitude into x plus 2 का magnitude. Here magnitude का बदल में हम लिख सकते हैं क्योंकि ना x minus plus 2 is equal to here x plus 2 because both are positive numbers. Here the maximum value of x is 2. So that's how you can write x minus 2 का magnitude into x plus 2 is less than epsilon. Here x minus 2 का magnitude is equal to 2 plus 2. X minus 2 का magnitude is equal to 2 plus 2, which is less than epsilon. Why? That is the maximum value of x is 2. Now it comes to 4 into x minus 2 का magnitude is less than epsilon. That implies x minus 2 का magnitude is less than epsilon by 4. This you taken this, it comes to what? That means x minus a का magnitude is less than epsilon by 4. If you take epsilon by 4 is equal to delta, it reverse process also true. So reverse process also true. That's why it is double implies you taken. Then for any epsilon is greater than 0, we can choose the epsilon number, sorry, delta number such that delta is the minimum value of epsilon by 4, comma 1. What the minimum here? Epsilon by 4. So delta comes to epsilon by 4. Now limit x square at x tends to 2 is equal to 4 will come. So that is the result. Hence proved. Another question also take. This is the question here. Prove that limit x plus 2 का root over at x tends to 7 is equal to 3 when epsilon is equal to 0.2. According to the definition of limit, fx minus l का magnitude is less than epsilon when x minus a का magnitude is less than delta. Let you first take fx minus l का magnitude is less than epsilon. That is fx का value x plus 2 का root over minus 3 का modulus less than epsilon. That implies x plus 2 का root over minus 3 का magnitude less than 0.2. That is here you know that when x modulus is less than a, that means minus a less than x is less than a will come. This is the definition, modulus definition. According to the modulus definition, here the value comes minus 2, 0.2 less than root x plus 2 root minus 3 less than 0.2. Then that is 3 is both side multiplication, addition is there. Here also addition, here also addition, here also addition. The value comes 2.8 less than x plus 2 का root over less than 3.2. Now squaring both sides. Why? That is square root हटाने के लिए after squaring 7.84 less than x plus 2 less than 10.24. That is 5.84 less than x less than 8.2. Why? That is 2 which is subtracted in both. So similarly, it is converted into x minus 7. Why? 7 is the a. That's why x minus 7 means 7 both multiplication. This subtraction is here. So x minus 7 here minus 1.16 here that is a minus 7 here that is a minus 7 here that is a minus 7. That is minus 1.16 is less than x minus 7 less than 1.24. Now it is a x minus 7 ka modulus is less than 1.16 according to this rule. This is a looks like x minus a ka magnitude less than delta. Let's say delta is equal to 1.16. You taken epsilon is equal to 0.2. Here delta is equal to 1.16 will come. So that's why limit root over of x plus 2 at x tends to 7 is equal to 3 comes. Now comes to another definition. What the definition say? Will tell. What the definition tells, a limit exists if and only both corresponding one-side limits exist and are equal. Then that's why that time limit exists. Limit f of x at x tends to a is equal to L for some number L. If and only limit f of x at x tends to a minus, the limit f of x at x tends to a plus is equal to L. That means here at x is equal to a. This is a minus means a minus h. A plus means a plus h. H is a small change, small value, small change. लेफ्ट साइड स्मॉल चेंज हुआ, राइट साइड स्मॉल चेंज हुआ. इसी का लेफ्ट साइड में जो लिमिट वैल्यू लेंगे उसको हम लेफ्ट हैंड लिमिट बोलेंगे. राइट साइड में जो लिमिट वैल्यू लेंगे उसको राइट हैंड लिमिट बोलेंगे. इसके अंदर जो वैल्यू लेंगे तो उनको फंक्शनल वैल्यू f of x at x is equal to a, that means f of a बोलेंगे. If left hand limit is equal to right hand limit, then limit exists. If LHL is equal to RHL, then limit exists. That is limit value exists. If LHL is equal to RHL is equal to f of a, then fx is continuous at x is equal to a. तीनों सेम होगा तो इसको हम बोलेंगे कॉन्टिन्यूअस. दोनों लेफ्ट राइट सेम होगा तो इसको लिमिट एग्जिस्ट. तीनों सेम होगा तो इनको हम बोलेंगे फंक्शन कंटिन्यूअस एट द पॉइंट x is equal to a. एक फंक्शन कंटिन्यूअस मींस ईच इंटरवल में वो कंटिन्यूअस होगा. ओके, नेक्स्ट अनदर कंडीशंस अंडर व्हिच लिमिट्स डू नॉट एग्जिस्ट. लिमिट किस कंडीशन से एग्जिस्ट नहीं है? फर्स्ट कंडीशन, तो लिमिट्स ऑफ fx एज x टेंड्स टू a does not exist. fx approaches a different number from the right side of a, and then if it approaches from the left side of a, then that time limit does not. Left side भी approach करेगा, right side भी approach करेगा. Different approach means LHL is not equal to RHL. That means here left side x is equal to a. This is left side means a minus s. This is right side means a plus s. लेफ्ट साइड जो वैल्यू है, राइट साइड जो वैल्यू आएगा वो वैल्यू डिफरेंट होगा, अलग होगा. मतलब LHL is not equal to RHL. That time limit does not exist. Another concept. fx increases or decreases without boundary point as x approaches a. f increases or decreases without bound, कुछ बाउंड नहीं है. एज एक्स अप्रोच ए, एक्स अप्रोच होने के बाद कुछ इंक्रीज भी नहीं होगा, कुछ डिक्रीज भी नहीं, विदाउट बाउंड, इधर इंक्रीज और डिक्रीज विदाउट बाउंड्री पॉइंट एज एक्स अप्रोचेस ए. देन अनदर fx ऑक्सिलेट बिटवीन टू फिक्स्ड वैल्यू, दो फिक्स्ड के अंदर वैल्यू के अंदर fx सपोज फिक्स वैल्यू दिया, then x approaches a value, when x approaches some value, that time दोनों वैल्यू दिया है, मतलब ऑक्सिलेट, इधर भी आ रहे उधर भी आ रहे, उसका मतलब क्या है, वो वायोलेट कर रहे डेफिनेशन को, उस टाइम भी लिमिट डज नॉट एग्जिस्ट. These are the condition which limit does not exist. Another definition of the here, if limit f of x at x tends to a is equal to fa, then the function fx is continuous at x tends x is equal to a or x tends to a and limit exists. ये कंटिन्यूस होगा तो लिमिट एग्जिस्ट करेगा, तो लिमिट एग्जिस्ट करेगा इसका मतलब कंटिन्यूस नहीं होगा कि होगा उसका पता नहीं. So this is the another definition of a limit. Now come to the properties of the limit. Different properties: addition, subtraction, multiplication, division. The different properties are there. This is one property. Let limit f of x at x tends to a is equal to L. Limit g of x at x tends to a is equal to m are exist. Two function limit exist. Here, limit at x tends to a, f of x plus gx is equal to limit f of x at x tends to a plus limit f gx at x tends to a is equal to L plus M. Similarly, second property, limit x tends to a, f of x minus gx, that is equal to limit x tends to a, fx minus limit g of x at x tends to a is equal to L minus M. Then 3, limit x tends to a f of x into g of x, that is equal to limit x tends to a f of x into limit x tends to a g of x is equal to L into M. Then fourth property, limit x tends to a fx by g of x, that is equal to limit x tends to a f of x by limit x tends to a g of x, that is equal to L by M when g of a is not equal to 0. Fifth property, limit x tends to a k is equal to k, where k is any real number. K is any real number. Another property, okay, what another sixth property? Here, sixth property, that is the limit k into f of x at x tends to a is equal to k constant, where k is a constant here. K is a constant, that is belongs to real number. So k into limit f of x at x tends to a. Similar limit at x tends to a f of x का power p is equal to वो limit f of x at x tends to a का whole power p. Similarly, limit root p of f of x at x tends to a is equal to limit f of x at x tends to a whole root p. Similarly, eighth property, limit at x tends to a log fx base b is equal to log base b limit f of x at x tends to, means limit अंदर घुस जाएगा, log बाहर आ जाएगा. These are the properties of limits. Next video, I will discuss in different format. One is the determinate, another is the indeterminate format. In indeterminate format, different methods are there, and in different method, different purpose के लिए हम यूज कर सकते हैं. इसके बारे में हम पढ़ेंगे. Thank you. Please subscribe and share, and some approach also will come. Better approach also come in next video.